Hello, hello. Hopefully we're doing good today. We are going to be filling out our fractions foldable today, excuse me. So it is this one that we got in class. If you did not get this, then just make sure that you get this from me at some point so you can fill it out so that you have this available for your notes, okay? So there are 3 sections. There's adding, subtracting, multiplying, and then also dividing. So we're going to start with the first one, which is adding, subtracting. So in there, we're going to start with like fractions, meaning fractions that have a common denominator already. So if it has a common denominator, and we're going to make little notes here. So if your denominator is the same, so you should be writing this in your foldable along with me. So if the denominator is the same, then you just add or subtract depending on what it's asking you to do. Add or subtract across the top. Okay, and then what's common is then people think that you need to add or subtract on the bottom, but you don't. You keep the denominator. So keep denominator the same. And then the last thing that you should always do for fractions, no matter what, is if you can, you need to reduce the fraction. Can you always reduce the fraction? No. But if you can, you should. Okay, so that makes this go really quick, right? I have a 5 on the bottom, 5 on the bottom, so the denominators are the same. So I'm just going to add straight across. 3 plus 1 is 4. The denominator stays the same, and in this case, I can't reduce it. Okay, so basically, if I have 1, if this whole block is 1 whole, and I've split it into 5 even pieces, if I have 3 of those pieces, right, 3/5, and then I added in another 1/5, now I have 4/5. So hopefully that kind of makes sense how we got that. So now I have 1, 2, 3, 4. Same thing for example 2. My denominator is the same. It's 7. So I just subtract straight across. So 5 minus 2 is 3. And then the 7 is going to stay. And again, if I have 1 whole, I don't know where this top line went, but we can go with it. If I have 1 whole here and it's divided into 7 parts, and I have 5 of them, 1, 2, 3, 4, 5, but I then take away 2, how many now do I have? And it's 3. So hopefully that makes sense. So if you have fractions with a common denominator, it should be pretty quick on how to simplify those. So now we're going to look at if you are adding or subtracting without common denominators. Okay, so like here in example 3, I do not have a common denominator, right? 1 is 3 and 1 is 9. So super important that we need to get a common denominator. So the question that we ask ourselves is there a number that both 3 and 9 go into? Okay, and hopefully we see that 3 can go into 9 and 9 also goes into 9. So I can actually rewrite these fractions with a 9 on the bottom of them. And I kind of like to do this where I have blank fractions, but I know that the bottom is going to be 9, right? So I can ask myself, what do I have to multiply 3 by to get me 9? And the answer is 3, right? 3 times 3 is 9. If I multiply the bottom by 3, I also have to multiply the top by 3. So then that gives me, and I'll never get the same color purple back, but that's okay. That gets me 3. Okay, so 1 times 3 is 3. 3 times 3 is 9. And then over here we say, what do we multiply 9 by to get 9? And that's 1. So I multiply everything by 1. You don't have to do this part if you can skip it, that's okay. 9 times 1 is 9. 5 times 1 is 5. So then now I have a common denominator, right? And I can just multiply across. So 3 plus 5 is 8, and then the denominator stays the same. So hopefully that makes sense. If we want to look at the model here, this is split into 9 equal pieces. So I have 1/3, but I need to make that into 9s, right? So here's 1/3, here's 1/3. So I kind of split that into thirds now. This is 1/3. So if I have 1/3, that is 1, 2, 3, 3 of 9 pieces. So that's kind of a visual of the 3/9. And then this other one, I have 5/9, 2, 3, 4, 5. Okay, so I have the 3/9 here, and then the 5/9 here, and so then if I add them together, I get the 8/9. Same thing here. For the last one, I have to get a common denominator, so I'm going to ask myself, what are two numbers that, what is a number that both 2 and 8 go into? And so hopefully we realized that 2 goes into 8, and 8 also goes into 8. So I kind of want this 8 on the bottom. And I have a double negative. Do you see this? I have minus, minus. So I'm going to go ahead and make that a plus because it's double negative. So then the question is, I have a 2, but I want it to be 8. So what do I have to multiply? So 2 times 4, which means I also have to multiply the top by 4, right? So that gets me 4 times 2 is 8. 4 times 1 is 4. Then here, again, if it helps to do the ones, that's fine. 8 times 1 gives me 8, so I need to multiply the top by 1 as well, which gives me 8 on the bottom and 7 on the top. The reason it's not a -7 is because I got rid of this double negative here, and I turned it to positive. And now I can just add. So if I have 4 plus 7 is 11 over 8, and that's it. For the model, there's no way I'm going to be able to draw these circles into 8ths, so we're not going to do the model. So summary is that you always need a common denominator. So that's our summary on adding or subtracting fractions. You always need a common denominator when you are adding or subtracting. So hopefully that's a good little review. As always, if you need help, please, 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 please reach out. Otherwise, hopefully you're feeling okay, and we are going to actually move on to multiplying now. Okay, so on the next little flap is multiplying a fraction by a fraction. So if we have an example such here as example 5, -3 over 5 and times -1 over 4, how do we multiply those fractions? So the key here is that we multiply straight across. And then, as always, and even more important, don't forget to reduce. Okay, so multiply straight across and reduce. So in this case, we just multiply, it's a little arrow, straight across both ways. So -3 times -1 is +3. 5 times 4 is 20. And then we ask ourselves, can we reduce that? The answer is no. So that's it. Here's my answer. All done. Okay. For example 6, I'm going to show you 2 different ways to do it, but let's do it the way that we just did first. So 5 times negative 12 is negative 60. I'm just multiplying straight across. 12 times 7 is 84. And then I can reduce, meaning I know that 12 goes into both of these numbers, so I'm going to divide by 12. And down here too, I'm going to divide by 12, since I know 12 goes into both of those. And negative 60 divided by 12 is negative 7. Wow, that's a 5. Negative 5, I mean. And then 84 divided by 12 is 7. I was ahead of myself. And I can't reduce that any further either. There's no number that goes both into 5 and 7. So that is one way to do it. I am going to show you another way here. And I just want to point out, if this way that I'm about to show you, if that makes sense to you, you can do it this way. But if what I show you right now doesn't make any sense, then you don't have to do it this way. You can do it how we just did over here, okay? But I'm going to rewrite this problem. So 5 times 12, 5 over 12 times negative 12 over 7. And so we can do what we call cross cancel. So looking here, I see that I have a 12 over on the bottom left and a negative 12 on the top right. And so there's a common number that goes both into 12 and negative 12, and it's 12. So I can divide 12 by 12, and I get 1. And I can divide negative 12 by 12 and get negative 1. So all I did was divide by 12. And then I can multiply straight across. So 5 times negative 1 is negative 5. And then 1 times 7 is 7. So you get the same answer either way. But this is just kind of doing the reducing before you multiply, and then this is doing the reducing after you multiply. So again, whichever one makes sense to you, that's the one you should do, okay? I'm going to go ahead and clear this, and then we'll look at the second half of this page, which is right here. Okay, so now we're looking at multiplying an integer by a fraction. An integer is just a whole number. So my example right here, right, is just a whole number. So a whole number by a fraction. So the question is, how do I make that 9 a fraction, right? So we're going to make a little note here to make the integer, so the whole number, integer, a fraction. By putting it over 1. By putting it over 1. Okay, so I can make this 9 a fraction by making it 9 over 1. And then from there, I can just multiply straight across. So 9 times 14 is 126 over 1 times 15 is 15. And then we ask ourselves what number goes into both of those. And I've already done some work, so I know that 3 goes into both of these. Okay, again, that's some calculator work that you can do, is just to figure out what number goes in. So 126 divided by 3 is 42. And 15 divided by 3 is 5. Boom. Okay. Using the other method, so I have 9 over 1 times 14 over 15. I do see that there's a common number between 9 and 15, and that common number is 3. So 9 divided by 3 is 3, and 15 divided by 3 is 5. There is no common number between 1 and 14, so those just stay. So now I can just multiply 3 times 14, which is 42, and then 1 times 5 is 5. So again, either way, whichever way makes sense to you, that's the way you do, okay? So it does not have to be perfect, or it does not have to be both ways. So just pick one, okay? The last example for multiplying is multiplying a mixed number by a fraction. So really quickly, we're going to review how to change this to an improper fraction. So we're going to make a little note to change the mixed number. My pen's starting to get jumpy on me. The mixed number to an improper fraction. So we don't really use mixed numbers anymore. A mixed number just means, right, that I have this whole integer here as well as this little fraction. So we don't really use this anymore. It's much better just to leave it as a normal improper fraction, okay? So let's review how to change this anytime you have a mixed number. So I'm going to write this 2 to the 1/7 really big so I can manipulate it. So what you do is you take your whole number and you multiply it by the denominator of the fraction. So 2 times 7, you multiply that. And then whatever you get, you would add the numerator, the top. Okay? So if we do it this one, 2 times 7 is 14, right? 14 plus 1 is 15. So I get 15 over, and then your denominator just stays the same, 15 over 7. Something to point out, if this 2 was negative, it would stay, you would still ignore the negative and then just do 2 times 7 plus 1, and then just make it negative again at the end. So just be careful if it's negative. But this is nice because then now this just tells me that this is 15 over 7 times 7 over 10. So again, 2 ways to do it, but I can just multiply straight across. 15 times 7 is 105. And then 7 times 10 is 70. And I see that 5 goes into both of these. So let's see what that does for us. I don't actually have my calculator. So 105 divided by 5 is 21. And 70 divided by 5 is 14. Now I can clearly see another number that goes into both of these, which is 7. All right, 7 goes into both of those guys. So I can reduce again. So 21 divided by 7 is 3, and 14 divided by 7 is 2. So I get 3 over 2. So that is one way to do it. The other way to do it, the cross-canceling way, so I have 15 over 7 times 7 over 10. And so cross-canceling, I see a 7 and a 7, so I can divide both of those by 7. So that gives me 1, right? 7 divided by 7 is 1. 7 divided by 7 is 1. And then here, 15 and 10, I see that 5 goes into both both of those numbers. So 15 divided by 5 is 3, and then 10 divided by 5 is 2. So then when I multiply this straight across, 3 times 1 is 3, and 1 times 2 is 2. So again, I get the same answer either way. It just depends on which way makes more sense to you and which way you like. Okay. If you have any questions on multiplying fractions or anything like that, make sure you reach out, ask questions, and like today, because again, if you just let one day roll by, I don't want things to snowball on you and get kind of a little overwhelming and out of control. So the last thing that we are going to look at is dividing fractions, and then we'll be done. Okay, so our last little bit of the foldable is dividing fractions. And so hopefully we'll remember the rule for dividing, which is copy. I'm going to write it nice and big. Copy dot flip. Sometimes you've heard it maybe as like keep change change, or keep change flip, or copy dot change, or any sort of thing like that. It's all the same thing, okay? So however you learned it is fine. But all it means is that we're going to copy the first fraction. So the first fraction does not change. Okay, so that stays the same. So copy a first fraction. Then we multiply instead of divide. So that's where the dot comes in, right? Because that's our symbol for multiply. So multiply instead of divide. And I'm going to run out of room, but I'll try. And then the lastly is to flip the second fraction. Okay, so copy the first fraction, multiply instead of divide, flip the second fraction. So let's look at this first example. So what this tells me is I'm going to, because I'm dividing, right? I'm going to copy the first fraction. So the first fraction is going to stay the same. Then instead of dividing, I'm going to multiply. So there's the dot. And then I'm going to just flip the second fraction so it becomes 5 over 4. And now it's just a multiplication problem. So we already went over multiplication. So we multiply from left to right, straight across. So 35 over 15 times 4 is 60. And then I can reduce this by dividing by 5. So 35 divided by 5 is 7, and 60 divided by 5 is 12. Boom. Again, you can do that shortcut. So 7 over 15, you can reduce first by cross-canceling 5 over 4. And by seeing that 5 goes into both of these. So 5 goes into 5 once, 5 goes into 15 3 times. So 7 times 1 is 7, and 3 times 4 is 12. So again, either way, whichever way makes sense to you, that's the way that you should do it. Okay, so it's the same thing here for this one. I'm going to, because I'm dividing, I'm going to copy my first fraction, and then dot, and then flip the second fraction. And we're just going to multiply straight across. So negative 5 times 3 is negative 15. And 12 times 2 is 24. And 3 goes into both of those. So negative 15 divided by 3 is negative 5. And 24 divided by 3 is 8. Okay. Or again, you can cross cancel. So I'm going to be doing it both ways on this foldable just so that you can see both ways if you want. So if we cross cancel here, 3 goes into both of these. So 3 goes into 3 once. 3 goes into 12 4 times. So I already reduced, and so then I can just multiply straight across. So negative 5 times 1 is negative 5, and then 4 times 2 is 8. Again, either way, you get the same answer. No big deal. So it's basically multiplication. You just have to set it up first by doing your copy dot flip. So what we're going to do, the second half of that page is dividing a fraction by an integer. Just gotta find it. Dividing a fraction by an integer, and then also dividing a mixed number by a fraction. So similar to what we did for multiplying. Okay, so same thing here. I have to make this a fraction. So I'm going to make it a fraction by making it over 1. And then I'm going to copy dot flip. So negative 9 over 10 times, flip the fraction, so I get 1 over 6. And if I multiply straight across, I get negative 9 over 60. And I know that 3 goes into both of those, so negative 9 divided by 3 is negative 3, and 60 divided by 3 is 20, and I can't reduce that anymore, so that's it. If I go do the other method, negative 9 over 10 times 1 over 6, I see that 3 goes into 9 and 6, so 3 goes into 9 3 times, so this becomes negative 3. And 3 goes into 6 2 times. And so that gives me negative 3 times 1, which is negative 3, over 10 times 2, which is 20. And same thing, you get the same answer. I know I'm going a little bit faster, and I'm sorry, but just know that you can always pause it or go back and rewatch the videos if you miss something or if something isn't making sense. And then lastly, we have a mixed number by a fraction. So same thing, I need to get rid of this mixed number. Okay, so I'm going to, if you remember, right, I multiply 4 times 10, and then I add 3. So 4 times 10 is 40, plus 3 is 43, over, and then this number, the denominator stays the same. So 43 over 10, here's the dot, and then I'm going to flip. So again, if I multiply straight across, 43 times 5 is 213. 10 times 3 is 30. Sorry, this is 215. Wow. I was like, that doesn't make sense. 215. Now 5 goes into both of those, so if I reduce, I get 43 on top and 6 on bottom. If I were to do it the other way, so 43 over 10 times 5 over 3. 5 and 10. So 5 goes into both of those. So 5 divided by 5 is 1. And then 10 divided by 5 is 2. Here, 43 and 3 are prime, so that doesn't actually reduce. So I can't reduce those. So 43 times 1 is 43. And then 2 times 3 is 6. Woohoo! The only other thing I want to show, and I'm going to leave a little space here on the right, is what happens. I know I said it earlier, but let's actually write it. What happens if you have a negative mixed number, like negative 3 and 2/7 or something like that, right? How do you get that to be an improper fraction? And the trick is to ignore the negative. So you want to ignore the negative until the end. So ignore the negative until the end. So I'm going to ignore this negative, and I'm just going to go ahead and multiply. So 3 times 7 is 21. right? Plus 2 is 23. So I have 23 over 7. And then you can take this negative and put it back in to make it negative 23 over 7. The difference is if you don't do that, you get negative 3 times 7, which is negative 21, plus 2 is negative 19. So just make sure, ignore, the easiest way is to just ignore the negative, convert it, and then put the negative back in. Okay, so that was a quick refresher on all things with fractions, adding, subtracting, multiplying, and dividing fractions. So you will have some practice now on that. If you need help, please reach out, email, remind, whatever you need. Let me know right away so that I can help you. And I will see you guys next time.